This is our exponential and logarithms video for the exam review. And work through all of the problems that are in the Unit 5 portion. All right, so starting with number 1, it says write the following logarithms in equivalent exponential form. This is where we took the base of the logarithm, we did that little curly Q thing where we said 2 to the 9th power equals 512. So you would write it this way, 2 to the 9th equals 512. When you're given numbers, it's really nice because you can actually verify is 2 to the 9th 512. Right here, same thing, 1/3 to the negative 9th is 19,683. Now in C, you have to remember that the base of the common logarithm is 10. Right? If there's no base, it's implied that the base is 10. So this would be 10 to the 4th is 10,000. Right, and finally, for this last one, just like C, you have to remember the base of the natural logarithm is e. So here, it would have e to the 0 power equals 1. For number 2, we're going to go the other way. We are given exponential form, and we have to use logarithmic form. The same little curly Q idea still works here. We have this 8, which is our base. So log base 8 of 4,096 equals the exponent of 4. Remember, the logarithm is the exponent. It always equals that value. All right, same thing here. We have log base 17 of 4,913 equals 3. And C, log base A of M equals G. Now here for D, I'll write it two ways. You can write log base 10 of 1 over 1,000 equals negative 3. But for our common log, the convention is that we don't write the base of 10. So a lot of times you'll see that written as just log of 1 over 1,000 equals negative 3. Either one is correct. It doesn't matter which one you do. All right, number 3 now says use that definition of a logarithm. And that's going back to what we did in number 1 and number 2 here, this little curly Q idea, to rewrite this logarithm in exponential form and solve for the value of x. So, to write this problem, you would have 3 to the 8th equals x. So you'll just go ahead and grab your calculator and calculate what is 3 to the 8th power, which is 6,561. That is the value of x. Oops. Right, and then that's all there is to that problem. For B, you'll have m to the 5th equals 1,024. Now, if you remember your exponents, this one's not too bad, but if you don't know what to the 5th is 1,024, you're going to take the 5th root of both sides, which on the TI-84 calculators, you hit the number 5 for the 5th root, then you're going to go to math, and you're going to choose option 5. That turns it into a 5th root of 1,024. Tells you that that value is 4. So m equals 4 here. All right, the next one would be 4 to the 3rd equals 2x. Well, 4 to the 3rd is 64, so we'll simplify that to be 64 equals 2x. And to get x by itself, we're going to divide by 2. So that gives you that the value of x here is 32. All right, last problem. 6 to the 3rd equals the whole quantity 2x minus 6. Well, 6 to the 3rd is 216. And we're going to solve for x. So we'll start by adding 6 to both sides, which is 222 equals 2x. And when I divide by 2, I get 111 equals x. Okay, so 1, 2, and 3 of this exponentials portion all just use the definition of a logarithm and exponential. How can I rewrite them so that I can solve for a value of x? Okay. Number 4 is now solving an exponential function. Okay, so here's the difference. Number 3, we solved a logarithm. So we had to turn it into an exponential, right? This is an exponential. I converted it to an exponential to solve. In number 4, I start with an exponential, and I have to use a logarithm. This is the one where we told that story about being in the woods and playing basketball, and you have to throw a log at the problem in order to get the x from the exponent. So A is the simple problem here. You're going to take the log of both sides. But remember, when you take the log of something with an exponent, that x pops down in front. So you can write this as x times log of 2 equals log of 64. You have to take the log of both sides of the equation. To get x by itself, you divide by log of 2. Right, now, when you type this into your calculator, make sure that you use parentheses after the log of 64 before you take the log of 2. That'll give you that x is the value of 6. There you go. B is a little more complicated, but not too bad. Before you can use the logarithm on the e of x, you have to subtract 10 from both sides. So we'll have e to the x equals 62. Now, because I have e as the base this time, you're going to use the natural logarithm of both sides. Right? The same exponent rule applies. That x is going to come down in front of the logarithm. We'll take the natural log of 62. Now, it's worth remembering that the natural log of e is equal to 1. So that kind of just goes away. You can cross it off, because what you really have here is that x equals the natural log of 62, which you can now just type into your calculator. 4.127, that's what I got. All right, and that would be the value of x. All right, in E, just like in B, before you can actually take the log of both sides, you have to move the coefficient 2 outside of the parentheses. So we have to divide first, where we'll get 4 to the x equals 428. Now this problem looks just like the problem in A, where you're going to take the log of both sides and bring the exponent down in front. We'll divide both sides by log of 4. And we'll type that into our calculator. Log of 428, parentheses, divided by log of 4. We have 4.371. We'll round there. All right, and there you go. All right, so those are solving exponentials using logarithms. Easy problems. We'll do a couple more challenging problems here on the next page. But let's talk about number 5. Let's do some exponential modeling. All of these formulas along the top of the page will be on your exam for you to reference. Okay? So number 5 says the population of a town in Mississippi can be modeled using this equation. T is the number of years since 2005. Well, it wants to know, does this model represent growth or decay? To determine that, you're going to look at the value in the parentheses, 0.89. Because 0.89 is less than 1, this is going to be exponential decay. Now, we want to know, what is the rate of decay? What percent are you decaying by? Well, when it's percent decrease, you have to take 1 minus the rate in the parentheses. 1 minus 0.89, which is 11%. 0.11, or 11%. Now it says, what's the population in 2005? That's the starting amount. How many people did we start with? Well, the population of this town was 26,894 people. So we've gotten all this information just from the equation. Now we want to know, what is the population of this town in 2016? Well, we have to figure out, we're going to use the same equation, but we need to know how many years since 2005 is 2016. You're going to use 11 for your time. That's 11 years since we started the model. So the population 11 years after you start, all you're going to do is put 11 in the exponent. So take a second, let's type that into our calculator. So 26 0.894 times 0.89 to the 11th. And it looks like if the population keeps going down by 11%, the population is only going to be 7,464 people. That's not a lot. 7,464 people. So the population drops a lot in 11 years, from 26,000 to 7,000. Okay. All right, number 6 is a similar question. This time we're talking about the value of a magazine after it was purchased is modeled by this function. This time is a growth or decay. Well, we look at this 1.09 in the parentheses. Because 1.09 is greater than 1, it is exponential growth. The rate of growth, you look at the value, you kind of like, I can't really cover it up with my hand here, so I'll scratch it off for a second. You ignore that 1. All you have left is 0.09, which is 9%. That's the percent that you are increasing by. It's the number after the 1, the decimal. So this magazine raises by 9% every year. The magazine started, that's your starting rate right here, at a cost of $825. And we want to know its value 12 years after purchase. That's what you're going to let the time equal. So the value of this magazine in 12 years, you're going to put 12 in for the exponent and type that into your calculator. And it looks like in 12 years, this magazine is worth over $2,000, $2,320.45. Okay, so we'll round to 2 decimal places here because we are talking about money. Good. All right, now we have a little bit more work to do. We have to choose a model this time. It says that your grandparents give you a check for your birthday for $500, and you want to start saving money because you want a new phone. You find a certificate of deposit that earns 1.25% interest, compounded continuously. You want to find the formula that is appropriate for this scenario. Okay? So when it's compounding continuously, you're going to use the PERT formula with E. Right? So if it says actually compounded continuously, you're going to use that formula with E there. So let's set up the equation. We want to set up the equation to know after 8 years how much money will you have in your account. So we'll start with A equals. P is the principal, the starting amount that you got, which is $500. We have E. Now the R is the rate. Now the rate is 1.25, but that needs to be written as a decimal. So you're going to divide that by 100 to get 0.0125. And we have to know in 8 years what's the value. So 8 is our T. You can go ahead and type that exactly as it is into your calculator. 500 times E to the 0.0125 times 8. And you'll get, it's not a lot difference, but in 8 years you'll have a little over $552. Okay, so here we'll have the answer, $552.59. So that's all you'll have in 8 years. Now we want to know how long will it take the amount in our account to double, okay? Because it's going to take, we want like the double amount. We need $1,000 to buy our phone. So what we're going to do is we're going to let this doubled amount from our initial value is going to be $1,000, and we're going to put that 1,000 in our equation for A. We're going to say, okay, we want to know when is the amount equal to 1,000. Okay, so the rest of the equation stays the same, e to the 0.0125, but you're going to leave your variable as t because we're looking for time this time. All right, now to solve this equation, we'll start. You cannot use the log until you divide by 500. Right, you'll have 2 equals e 0.0125 times t. Because my base is e, we are going to use the natural logarithm here on both sides. So we'll take the natural log of 2. This whole exponent is going to come down in front of the logarithm. Now the nice thing about the natural logarithm is, remember, this natural log of e is 1. So it just kind of crosses off here. So all we have to do to get t by itself is divide by 0.0125. Okay, so we'll get our time equals. We'll use our calculator here. The natural log of 2 divided by 0.0125. And it tells you that it's going to take you over 55 years for that amount to double. So it would be 55.452 years. Oh my goodness, you would be, you'll be almost 70 at that point, if not over 70 years old. So you don't want to wait till you're 70 to have enough money to buy your phone. So that's where the next problem comes in. You don't want to wait that long. So you decide, instead of saving your money, you're just going to use a credit card. And your credit card charges 17% APR, that's the interest rate, compounded monthly, and you end up paying $850 for the phone. Now when it says that you compound monthly, that is this crazy looking exponential formula right here. That is the one where you're compounding over certain intervals. Okay? You make no payments on your credit card. You're not very smart and you don't make any payments for 3 years. What is your bill to the credit card company going to be for this phone? Well, let's set up the equation. The P is the principal and you charge, it says $850 times 1 plus. 17% is your rate. You have to turn that into a decimal, 0.17. The N is the number of times you compound. And it says you compound monthly, so that is 12 times per year. Your exponent is 12, the number of times the years, free. All right, now in your formula, you can use, if you have the fraction button, you should use it. If you don't, you can just type it straight into your calculator. But I'm going to use the fraction button. 1 plus 0.17 over 12 to the 12 times 3 power. And it tells you that you paid $850 for your phone. In 3 years, you would owe the credit card company for over $1,400 just because you didn't pay off your credit card bill. You owe $1,410.44. Now we want to know, if you just continued to not pay off your credit card bill, how long until it would reach a debt of $5,100? So like the previous problem, you're going to put that 5,100 where the A goes. So you'll set up 5,100 equals your entire crazy looking formula here. Although your exponent's going to be 12t because you're trying to find the time. So let's solve this. We first have to start by dividing by 850. You cannot do the logarithm until you divide by 850. Well, it's really nice. I think it turns out to a nice number at least. 5,100 divided by 850 is 6. So you don't have a crazy decimal. We did that nicely for you here. So you want to know until the amount is 6 times as large. So you have 1 plus 0.17 over 12 to the 12t. Now, in order to get that exponent out of the variable out of the exponent, you have to use the logarithm. We're going to use our common log this time. Log of 6 equals. That exponent's going to pop down in front, 12t times the log of this whole yucky looking mess. Before I can deal with the 12 and get t by itself, I need to divide by this logarithm on both sides. Okay, so we'll divide by log of 1 plus 0.17 over 12. Now, just so I don't have to write it again, I'm going to erase. I'm going to cross off what we have over here, because really I would rewrite the same thing anyways. I have this fraction equals 12t. Don't type it in your calculator yet. You need to wait until you're finished, because now you need to divide both sides, that whole fraction, divided by 12. That'll get you your time. So what this looks like in your calculator, if you forget, is you take your log of 6, divided by the log of that whole fraction here. Now you can hit enter here on your calculator, but before you write anything down, you we now immediately hit divided by 12. That is going to be the time. It would take 10 years of not paying your credit card bill to accumulate a debt of $5,100. Okay, so hopefully that reviews some of the solving exponentials for you. A couple more problems here. Here's a comparison question. It says Jim puts $2,000 in a bank account, and the bank account pays 4.9% compounded continuously. He wants to know that if he puts that $2,000 in the bank account, after 1 year, will he have enough money to buy a sound system worth $2,105? So will he earn $105 in interest over the year? So let's do that. We're going to compound continuously here. So it says we want to know the amount. If we compound continuously, that's that PERT formula. Jim starts with $2,000 in his account times E. Now R here, the rate is 4.9%, so that'll be 0.049. And our time is just 1 year. We just want to know what's the value after a year. So our calculator can do that work for us. 2,000 times E to the 0.049 times 1. You don't have to put the times 1. Oh, and it says that Jim only has $2,100. So it seems like Jim probably can't get that extra $4.50 here, and he's not going to be able to afford his sound system for Jim. However, Jim has another bank that he's trying to compare. So the first bank he went to that he wanted isn't going to work for him. Now he's going to try bank number 2. That gives you interest at 5.5% compounded semi-annually. So that's going to be this formula right here, the compounded over certain intervals formula. All right, so our principal is still $2,000. He's checking this bank out now. We'll have 1 plus, our interest rate here is 5.5%, which is 0.055. Semi-annually means you take interest twice a year. And we're taking interest twice a year just for 1 year again. So we're going to put that in our calculator to see if this bank is a better option for Jim. So 2,000 times 1 plus 0.055 divided by 2. That exponent is 2 times 1. Looks like this bank is going to be good. But Jim should go with his second option because he will get $2,111.51 at the end of the year. That's a good thing. Happy Jim right there. So he should choose the bank that can semi-annually compounds his money. All right, let's finish this unit up with some multiple choice questions. Some just basic things to know about exponentials and logarithms. It says the inverse of an exponential function. Well, the inverse of an exponential is not a line. It's not a quadratic. It's actually not even an exponential. It is a logarithm. That is why to solve an exponential function, you use logarithms. That's when you throw a log at it, because those are inverses of each other, opposite relations. All inverses, we talked about this back in Unit 2 review, I believe. All inverses reflect over the line y equals x. All right, and last two are about logarithm bases. The number 10 is the base of the common logarithm. The common logarithm is the one that's just log of a number. So remember, it's always log base 10 if you see something like this. Log of 25 would be log base 10. And the base of the natural logarithm, that's your ln here of a number. The base is e. All right, so that's your exponential and logarithms review here. I'll have other videos for Unit 6 and 7 up next